participants. My name is Dr. Sesugh Ande from Joseph Sawantaka University. I'm taking you on the fifth module, which is titled Pollution Prevention and Management. And under this module, we are going to look at it in three sections. The course is divided, like I said, into three sections, which comprises of the following topics. We're looking at hazardous materials. We'll be looking at preparation of pollution abatement action plans. We'll be looking at resource efficiency and pollution prevention and management. So the learning objectives are as follows for the section 1. You should be able to define the term hazardous materials, identify different classes of hazardous waste, understand the impact of hazardous waste on human health as well as the environment. You should also be able to explain how hazardous waste can be effectively managed. On the second section, you should be able to justify pollution abatement action plans, identify the various tools that are used for these action plans, state the benefits of CAP, identify the content of a waste management plan. Now, hazardous materials. What do you understand by hazardous materials? Or when we are talking about hazardous materials, what do they mean? They are any solid or liquid or gaseous substance or material that is radioactive, toxic, explosive, flammable, or otherwise physically or biologically detrimental to human health and environment. Now, I want us to look at some of the international conventions on hazardous chemicals and waste. We have about 4 of them here. One is the Basel Convention, which took place in 1989. We have the Rotterdam Convention, which took place in 1998. We have the Bamako Convention, which took place in 1991, and the Stockholm Convention, which took place in 2001. There are enough laws and policies on hazardous waste even in Nigeria. The challenge we have here nationally is the enforcement of these laws. And it is very important that we see that waste that is generated is managed properly or possibly avoided. And for us to be able to achieve this, we need to enforce the laws that are in the land. The Basel Convention established the following hazardous waste characteristics. It described them as explosive, flammable liquids, flammable solids, waste liable to spontaneous combustion, waste that emit flammable gases by reaction with water. They are oxidizing, they are poisonous, they are infectious and corrosive. The U.S. Environmental Protection Agency used about 4 parameters for classification of hazardous waste. And 1 is the flammability, 2, corrosivity, 3, reactivity, and toxicity. Now, a waste is determined to be hazardous waste if it is specifically listed on one of 4 lists represented as F, K, P, and U list found in that section. Now, the list F include waste from non-specific industrial sources such as solvents, sludges from waste treatment, because it is difficult to identify the sources of this kind of waste. So they are classified under non-specific industrial sources. You have a list K, which include waste that is generated from specific industrial processes such as organic and inorganic chemicals, manufacturing, pesticides, manufacturing petroleum and refining, and so on. Then the list P and U are similar in that both of them are pure or commercial formulations of certain specific unused chemicals as hazardous. They are discarded from commercial chemical products such as acetone, ether, benzene, methyl alcohol, phenol, and chloroform, etc. These ones are in their pure state. Now, exposure to hazardous waste As human beings, in particular, there are a number of routes or pathways through which these hazardous waste enter into our systems. One of them is inhalation. You have ingestion, you have absorption. It could be through injection. And because these hazardous wastes are toxic, they are corrosive, they have specific effects on human beings. And you have a number of them lined there. You have the source and then the health effects. They are carcinogenic. They can lead to kidney damage. They can lead to poisoning. They can lead to respiratory diseases. They can lead to lung and nasal cancer, headaches, nausea, and so on. This is the chemical hazard identification. It's a system that helps us to know how toxic or how corrosive a particular hazardous material is. For instance, you have the health hazard. It's given a number 4. It means deadly. You have 3, which means extremely danger. You have 2, hazardous, 1, slightly hazardous, and 0 represents a normal material that does not cause any harm, for instance. And we have specific hazards. You have the oxidizer, which is presented as OXY. You have acid, which is ACID. You have alkali, ALK. You have corrosive, COR. You have use no water. It's given that sign. And then you have radiation hazard. So they're giving all these signs that you have here, and so on. Then, there is need for us to manage these hazardous waste when they enter the environment or when they enter the system. And there are various ways in which we can manage these hazardous materials when they get into the environment, or we can even prevent them from getting into the environment. So this gives an overview of how we should be able to manage these hazardous materials. The first one there is remove, which indicates that we should try as much as possible to avoid to generate it. Then the second one is reduce. In case where it is generated, we should generate less by carrying out better management and material substitute. Then you have reuse. We should be able to reuse it in its original form, or recycle, or recover, or treat before dispose. Then there is a collection and transport system of hazardous or chemical waste. This helps us or guides us on how we could transport or collect these hazardous waste. And we have a number of procedures or a number of steps. One, we have the transport permit. And here it means transportation should only be carried out by establishments that are licensed to, deal with these hazardous materials. And then you have the collection schedule, which here it has to do the rotation schedule for waste collection. It must be adequate for quantities of the waste to be transported, preventing accumulation of such waste on site. And then you have a vehicle capacity. The vehicle that is going to be used in transporting or carrying these hazardous materials should have enough space to be able to carry them, and transport them. Then you have the signs. The vehicles must be clearly signed, indicating the type of waste that is transported. It's very important. And then safety equipment. You have vehicle washing, vehicle routing, garages, and driver training, and so on and so forth. Then, the storage of hazardous waste. How these wastes are stored is also very important. And that is what this section is going to talk about. Storage areas where these hazardous materials are going to be stored should be properly stored on site. What we are saying here is that the hazardous material should be properly stored on site. And the storage areas should be away from public places in order to prevent harm to the public. And persons who are exposed to waste should be of adequate size for the waste quantity to be stored. Access to the storage should be prohibited for unauthorized persons. In addition, hazardous waste storage practices must minimize possibilities of contamination of soil and groundwater. Then the storage containers need to be clearly labeled, and they should be inert. That is, they should not be able to react with the material in no way. The containers must be labeled with clear signs indicating their content and handling requirement and the associated hazards. These are examples of the containers in which hazardous waste are usually stored in. they are clearly labeled here. Then there is need to also carry out treatment. And we have about 4 treatment processes of hazardous waste. We have the chemical, we have the physical, we have the biological, we have thermal, and the land filling. The chemical has to do with neutralization of this waste with an alkali or alkali. You know that when an alkali reacts with an acid, it neutralizes the acid. So where the chemical is acidic in nature and you want to treat it or deal with it, you need to react it with an alkali. In doing so, the acid, which is the waste, for instance, now, is neutralized. And then we have oxidation. Here is using common oxidizing substances, such as hydrogen peroxide or calcium hypochlorite, to oxidize some of these harmful chemicals. Then we have reduction, which is also a chemical process, which converts the inorganic substance to a less mobile and toxic form. Then you have hydrolysis, which involves decomposition of hazardous organic substances, for instance, with sodium hydroxide or a mineral material. Then we have the physical methods. Here has to do with stabilization. And stabilization here involves blending a semi-solid waste with a bulking agent to produce a coarse grain solids that can be transported. Here, the essence is to immobilize the chemical waste, or is to immobilize the hazardous material so that it won't be able to be transported, in the environment so easily. So the idea here is to encapsulate or is to immobilize. So when you mix it with cement, for instance, it does not concrete, for instance, it does not become mobile any longer. Then we have the sedimentation, which is a process that relies on gravity, to remove suspended solids from the aqueous waste streams, for instance. It can be carried out in conventional settling basins or clarifiers. It is applied to remove suspended solids heavier than water, and is a pretreatment step for many chemical processes. Then you have the biological methods. The biological methods here has to do with the use of microorganisms feasting on a particular hazardous material, therefore rendering it inactive. Then we have the thermal treatment method, which involves the use of heat in the process, applying heat to convert the waste into a less hazardous form. It also reduces the volume and allows opportunities for the recovery of energy from the waste. We have incineration. Incineration is also an aspect of waste treatment. And this one, it involves high temperature. High temperature. This is a process often described in the industry as thermal treatment, using special incinerators that burn waste materials to ash, heat, and flue gases. So high temperature incinerators at 1,100 degrees Celsius is a treatment method to destroy hazardous organic waste, including the organochlorines, such as polychlorinated biphenyls. We also make use of cement kilns. Kilns that are used for the production of cement clinker in the manufacturing of Portland cement are designed and operated in a manner that achieves the required parameter for the destruction of hazardous materials. Then we have dedicated sanitary landfills where these hazardous materials could be, trapped. Such landfills are dedicated solely for the containment of hazardous waste over a long period of time. The hazardous waste may or may not be encapsulated before placement in the landfill. But here, extra caution needs to be taken so as to prevent leaching of these materials into the water system. So this is a typical dedicated sanitary landfill for hazardous materials. Now we are moving into the second section, which is the preparation of pollution abatement action plan. Now, what is the justification for this action plan? It's to comply with national legislation in the country, to decrease pollution loads of the pollutants at their source, and to improve ambient air and water quality to protect human health at the workplace and in the communities. Then these are the tools that are required in carrying out pollution abatement action plan. The first two is the compliance action plan, and the second one is the waste management plan, and the third one is the integrated pest management plan. Now, the compliance action plan is a tool to achieve compliance with environmental legislation. It differs from legislative approaches as it gives enterprises the opportunity to make and implement an action plan rather than that the authorities describe mandatory measures that a non-compliant enterprise has to obey. The purpose of this plan is to, one, support pollution prevention and integrated pollution control. Is to also compare the factory environmental indicators, air emissions, waste effluents, and solid waste, with the maximum regulatory limits of the National Environmental Law and its executive regulation. Is to also understand the link between the environmental audit and the CAP and how to use the audit data in preparing CAP and develop compliance action plans. Now, the purpose and scope of CAP. The enterprises should plan their own environmental investments in the CAPs without receiving technical specifications from the environmental or industrial authorities. The enterprises should have independence concerning their economy, and they should plan the technologies they want to use by themselves, using any available knowledge and technical assistance from other sources. The authorities can provide knowledge on such services and on possible financial opportunities. Now, what are the benefits of CAP? One is environmental benefits. Two is economic benefits. This is the link between an environmental audit and a CAP. You have the environmental audit, you have the CAP. Environmental audit is a legal requirement, but CAP is not a legal requirement. Conducted for complying and non-complying industries. That's audit. But here, it is a strategy to face defect points indicated in environmental audit limited to the companies not complying with regulations. And the main objectives of audit are waste minimization, cleaner production, and cost saving and recovery. While here the main objective is to comply with environmental regulation regardless the cost saving or recovery. They look for improvement of opportunities in prime objective. They consider main legislation standards and regulation compliance. Audit should be conducted before CAP. In other words, audit is conducted before CAP, while good CAP relies on information that is obtained from a good audit. And its efficient self-monitoring system is a prerequisite. Here, efficient self-monitoring system is also a prerequisite. Then preparation steps for the CAP. We have a number of these steps. They are much. And I want to refer you to my slides to look at this format more creditably because of want of time. Waste management plan. Waste management plan. The purpose of the waste management plan is to ensure that all waste streams that are generated during the project are managed in accordance with all national requirements in an environmentally sound manner. The waste management plan will provide direction for practical and cost-effective management of waste generation throughout the beginning and the end of the project, including the storage, the transportation, the treatment, and final disposal of waste. This is a flexible document, and amendments will be incorporated if and when changes or other information are required to be included. Now, this is the content of a waste management plan. You have the responsibilities. It describes the task roles and responsibilities of the generator of the waste, the project manager who is managing the project, the generator representative, the site manager, and the environment and social specialist. It also describes the institutional framework related to the hazardous waste. Then you have the waste stream identification. Under this, it describes in a table the main waste streams, the type of waste, the quantity that will be generated during the project activities, along with the potential impacts they can cause if not adequately handled. Then also describes the waste management methods to be employed and discuss the measures and procedures that were taken to manage the waste generated by the project following waste management procedures. This is the content of a waste management plan. It's continuing. You have the waste labeling. It has to be labeled. The type of waste that is being generated has to be labeled. Is it in drums or bins? They have to be labeled, clearly labeled according to the appropriate color. And then you have the waste transfer, which indicates how the hazardous or non-hazardous waste will be transferred from site or off-site and so on. And then you have the emergency response, training and monitoring. Here you have to prepare an emergency response plan in case of fires and so on. Accidental spillage, mishandling of hazardous waste, leaking from the storage containers, accidents, collision, providing training to staff involved in the collision, storage, transport, and treatment of the hazardous waste. Then the third tool that is used is integrated pest management plan. Here it allows the government to make decisions on the strategy to be adopted for the safeguarding of obsolete pesticides, repackaging, transport, and storage. It allows the country to select the most appropriate disposal strategy and so on. It also factors in any social issues as determined during the assessment of the inventory data and identify any locations where resettlement of inhabitants may be required. That's the content of the integrated pest management plan. One is analysis of the policy, institutional, and legal framework related to one, the ability to manage the procurement, transportation, storage, use, and disposal of the products used in pest control and their package, and the ability to monitor and forecast the occurrence and extent of disease and insect pests, propose scientific management methods, and correctly select obsolete pesticides. So the baseline data should include the following: a summary of any previous waste management and pesticide disposal initiatives, and they are lined up, like that. So you can read the rest when you get the slide. Now, this is the third section of this presentation. It is resource efficiency and pollution prevention and management. Here we have to look at what resource efficiency means. Resource efficiency means using the earth's scarcely resources in a manner that is sustainable while minimizing impact on the environment. When you are using the scarce resources like water, for instance, in a sustainable manner, in such a way that it will not impact the environment, then what you are looking at or doing is resource efficiency. Now, the borrower will implement technically and financially feasible measures for improving efficient consumption of energy, which is a resource, water, which is a resource, and raw materials, which are also resources as well as other resources. Now, what do we mean by technical feasibility? Technical feasibility of such project is based on whether the proposed measures and actions can be implemented with commercially available skills, equipment, and materials, taking into consideration prevailing local factors such as climate, geography, demography, infrastructure, security, governance, and among others. Then when you're talking about financial feasibility, it is based on relevant financial considerations, including relative magnitude of the incremental cost of adopting such measures and actions compared to the project investment, operating and maintenance cost, and on whether this incremental cost could make the project non-viable for the borrower. Now, sectors that typically make significant use of resources include industrial production, resource extraction, water pumping, transport, agriculture, waste management, education, and health. Measures to efficiently use resources will integrate the principles of cleaner production into product design and production. Now, what constitutes the efficient usage of resource in project context? and country-specific. What constitutes the efficient usage of resources is project context and country-specific, but should be consistent with good international industry practice. In the first instance, the environmental health and safety guidelines. In accordance with environmental social standard 1, resource efficiency measures should be analyzed as part of the environmental and social assessment. In many industrial and commercial activities where the unit of output can be readily measured or defined, widely accepted benchmarks that describe performance in quantitative terms are available. For example, process energy used per ton of product is often an acceptable benchmark. Similarly, building benchmarks may refer to energy or water used per dwelling inhabitant or per guest night in a hotel, or energy used per unit area in other building type with corrections for climatic variation. In case the project uses potentially significant amount of water, which is a resource. We're looking at categories of resource efficiency use now. And the first one we're looking at is water use. So in case the project uses a potentially significant amount of water, or we have potentially significant impact on water quality, the borrower will have to adopt measures to the extent technically and financially feasible that avoid or minimize water usage so that the project's water use does not have significant adverse impact on the communities or other users in the entire environment. And these measures include, but are not limited, the use of additional technically feasible water conservation measures within the borrower's operation, the use of alternative water supplies, water consumption offsets to maintain total demand for water resources within available supply, and evaluation of alternative project locations. For projects with high water demand that have potential significant adverse impacts on communities, other users, or the environment, the following have to apply. Number one is a detailed water balance. A detailed water balance will be developed, maintained, monitored, and reported periodically. Two, opportunities for improvement in water use efficiency will be identified and implemented. And then you have specific water use measured by volume of water used per unit production will be assessed, and operations must be benchmarked to available industrial standards. Then we are looking at the second resource, which is the raw material use. You know that raw material use is an important aspect. Efficiency in use of raw materials and thereby efficiency in cost and labor can be achieved by eliminating and or minimizing the quantity used in the project. So if you are carrying out a project and you see that the raw materials you are going to use in that project are going to impact on the environment, or they will bring about, they will not be sustainable, then you have to find a way of minimizing the quantity that you are going to use, and so on. Selecting the most appropriate raw materials possible and reducing and recycling the waste. You could recycle to be able to get the raw material instead of going for new ones. The project that usually makes significant use of raw materials include road construction, housing, urban development, logging, mining, and chemical manufacture and processing. Now, this is also an aspect under this section, pollution prevention and management. The borrower will have to avoid the release of pollutants, or when avoidance is not feasible, then you need to minimize and control the concentration and mass flow of their release using the performance levels and measures specified in the national law of environmental health safety guidelines, whichever is most stringent. That is the one you need to use. So this applies to the release of pollutants to air, water, land due to routine, non-routine, and accidental circumstances, and with the potential of local, regional, and transboundary impacts. In some cases, end-of-pipe emission flows can be diluted to meet emission standards while maintaining the same aggregate emission of pollutants into the environment. Therefore, now, the borrower will have to apply the mitigation hierarchy also that is related to pollution prevention and management, namely to avoid the release of pollutants. If avoidance is not feasible, you minimize the release of pollutants by controlling concentration and mass flows on the basis of the national standards or the environmental health safety guidelines, whichever is more stringent. In case of the pollutants exceeding the national standards, the borrower will adopt the necessary mitigation measures so that pollutants to abide by the national standards or the environmental health safety guidelines within a specific timetable and corrective actions. Now, to address adverse project impacts on human health and the environment, the borrower will consider the following relevant factors, which are very important: existing ambient conditions in areas already impacted by pollution, the remaining assimilative capacity of the environment, existing and future land use, the project's proximity to areas of importance to biodiversity, the potential for cumulative impact with uncertain and or irreversible consequences, and finally, the impact of climate change. And impact on climate change and evaluation of project location alternative. We are going to end this presentation with the types of pollution, prevention, and management. One is management of air pollution. We know that pollution of air is something that everyone must prevent. Everyone must be able to see that the air that we use is not polluted. And when this happens, adequate measures should be taken in order to see that the air returns back to its normal state. Now, the management of hazardous and non-hazardous waste. We have already discussed the management of hazardous waste in our previous slides and even other modules possible. Management of chemicals and hazardous materials, management of pesticides. The best thing to do is to avoid, reuse where possible, minimize where possible, and then dispose. But when you are disposing, then it must be an environmentally, friendly way. Thank you very much.